Okay, so 5-2 properties of exponents and radicals. Yesterday you reviewed your Algebra 1 exponent rules, right?
I do that every day.
Okay. No. Okay, so here they are. You don't need to write them because you all did amazing yesterday. I didn't see many people do extra credit, but I said many. Okay. Do not turn around and talk again. You guys need to rein it in after lunch, okay? So, power, when you take a power times a power, you do what with them? Add them. When you do a quotient, you subtract. Power to a power, you power of a product, you distribute it over the product. Yes? And a negative exponent does what? Reciprocates. If you want to write them, that's fine. But also on this negative exponent, what if I have 1 over a to the negative m? What does that turn into?
A positive m, and you like added up the other one.
Is that what you're trying to say?
No, you listened to me yesterday.
Okay. Is that what you're trying to say? Because that didn't really make sense. Shh. Okay. So this rule is both of these. So it just reciprocates it, yes? There is no exponent that gives you a negative answer. If the base is negative, you may have a negative answer, but there is no exponent that will give you a negative answer. Am I clear? Mm-hmm. Now, I want to point out right here on this one, this power, not that one, this one right here, this power distributed over multiplication, yes? Or division. It also could work if I had a over b to the m, it would go to both. Yes?
Yes.
Okay, it does not distribute over that, does it? That means a plus or minus b times a plus or minus b, correct? So I just want to keep pushing that. Now we're going to today, what you did yesterday, we're going to do exactly the same thing, but if you look at my examples, what am I going to use today? Those fractional exponents. Have we been working with fractional exponents? Yes.
Yeah.
It's the same work, you now just have a fraction. So when you add fractions, you have to have what? Common denominators. So that's something you're going to have to be working on. Remember, like 1/3 is the third root, right? So 2/3 is 4 squared, the third root of 4 squared. Correct? So you're using those things we were using Monday and Tuesday combined with what you practiced yesterday. So I have rewrite using properties of exponents. So as long as the bases are the same, I can deal with these, right? So I have 81 and I have 81, so the bases are the same. And those are exponents. I hate how they write exponents, but those are exponents, yes?
Yeah.
Okay, so I have 81 to the 5/6 times 81 to the negative 1/3. So what do I do to my exponents?
Make them the same.
No. What, like, no. What do I do with my exponents when I multiply? Go back a step. The rules.
Oh, you add them.
You add them. That's, I just wanted you to go to back one step. That's all I wanted. So I have, now this one we're adding, but one of them's negative, so we're really what? Subtracting. And by this point, that happens all the time, right?
Yeah.
And then, yes, you have to get common denominators. I just wanted you to take it way back. Okay. So I have 5/6 and I have 1/3, so my common denominator is going to be what? 6. So 1/3 becomes what? 2/6. So I have 5/6 minus 2/6 is what?
3/6 or a half.
3/6, which is also a half. And what is 81 to the 1/2? 9. Because it means square root, right? Do you see how you're doing things? Like a week ago, you thought, oh, those are all weird, but it just kind of went, right? Because we stepped through it. Okay, so that was that. Well, I have 3 over 32 to the 2/5. That is horrible. That's a little better, isn't it?
So 2/6, right?
What?
Change it to 2/6.
No.
It's easier.
No, it's horrible the way it's written, not what it is. Okay, so what do I do with this 1/2?
Distribute.
I distribute the power in, yes?
Yes.
So I have 3 to the
Half.
half. And I have 32 to the,
6/5? No.
2/5 times 1/2 would be 1/5, yes?
Yeah.
Okay. So now I'm dividing exponents, so I need to do what? Oh, wait, do they have the same base?
No.
No, but can I get the same base?
Yeah.
Yes. Because 32 is 2 to, 30, wait, maybe not.
No.
If I could would I do that?
Yes.
Yes. 32 is 2 to the 5th. Is that right? 2 times 2 is 4. 4 times 4 is 16. Times 2 is 32. So I could simplify it and write it 3 to the 1/2 and 2 to the 5th to the 1/5, correct? What's 2 to the 5th to the 1/5? 2. So I have 3 to the 1/2 over 2. So I could simplify it, but could I do anything with the bases? No. So what it's saying is you need to use all of the rules you can to make it as simple as you can. Because I would much rather work with the square root of 3 over 2 than this up here, wouldn't you? Okay, so that's with numbers. And odds are we don't do it with numbers, we use it with variables, correct? So now we're going to do all these with variables. So I have x, y cubed over x to the 1/2, all to the 3/2. There's a couple ways we could do this. We can simplify the x's first and then distribute in the exponent, or we could distribute in the exponent and then simplify the x's.
Get away from me. Get simplify.
Okay, I agree. We should simplify this first and then distribute it in. Because I'd rather distribute it in once than twice, wouldn't you? Okay, so am I going to do anything with the y? No, because there's only one y. That's why I asked, right? No. Which one's bigger? 1, because there's a 1 on this x up there, right? Is 1 or 1/2 bigger? 1. We always should go to the bigger one, shouldn't we? So I'm going to have x to the first minus 1/2 y cubed all to the 2/3. So what is 1 minus 1/2? A half. So I have x to the 1/2 y to the 3/2. Now, doing it that quick, we still got common denominators. We just know that, right?
Yeah.
Okay. So now what?
Now we put it back over x to the 1/2.
You have to... No.
Not yet?
No.
Oh, we have to distribute.
You have to distribute. You already took the x to 1/2. Okay. So I have 1/2 times 2/3. Give me what?
1/3.
Yep. Because the 2's reduce. Okay. And then I have y to the 3rd times 2/3 gives me,
2/3.
should just be 2.
Okay.
Do you see that, Emma?
No.
Because your 3 and your 3 would reduce. You did it with your 2's. You just couldn't do it with your 3's, huh? Your brain says no more. Am I going too fast, guys? We're just applying those. Is it the same exact rules you did yesterday?
Yeah.
Yeah, just with fractions now. Okay, what do you want to do first on this one? Actually, there's only one thing we can do first.
Simplify.
Well, that's what we're doing.
Do I put the x over 1/2 underneath? Or x to the 1/2?
No, we're done with this one. Okay, right here, we took care of that x to the 1/2 right here, Olive.
What did
Oh,
you do
yeah, we
with
did.
it?
Okay.
It's right there. Right where this purple arrow is.
How do you just move it up?
Because how do you divide exponents?
Reciprocals.
You subtract them?
Subtract them. I thought you were reciprocating.
Oh.
Oh, never mind.
You have x divided by x to the 1/2, yes?
Yeah.
Oh.
So that'd be 1 minus 1/2.
I was really confused as to what you said. But I got it.
Okay. So next one. The only thing we can do first is what?
Distribute?
Distribute, because we have to follow order of operations. So this 2/3 goes in.
Oh, we're on a different.
Yep, we're done. So that gives me 2a to the 1/3 times a to the 2/3, b to the 1/3. And now I just multiply, right? I did the power to the power, now I multiply. Do I have any other other number to multiply 2 by? Nope, so it's just 2. A to the first, because it'd be 3/2, right? B to the
1/2? No, 2/3.
B to the,
2/3.
where are you getting 2/3? Isn't B to the 1/3?
Oh,
Yes?
yes.
Okay. I'm like, where are you getting 2/3? You had me confused.
Okay. So we just, with the 2A and then the A, we just distributed, which got rid of one of the A's, and then just gave us an A to the first? Or how do we get A to the first?
Because we have A to the 1/3 times A to the 2/3. What's
Yeah.
1/3 plus 2/3?
We do it? This is just one. That's what we said. That's what we did, right?
Mm-hmm.
If you just added the 1 to A, then why couldn't you do the same to B and then be 2/3?
What one?
Because the A's are common.
You have to have common bases. B's a B. There's only one B, so it doesn't change. Like, you have to have the same base. Other questions? Those are all really good questions, guys. Okay, so rewrite using radicals. Okay, so now we're going to go radicals, right? Or, sorry, exponents. So, cube root is what? What?
What'd you say?
What's the cube root? What exponent is the cube root?
The 3. Wait, no. The 5. What?
No.
16.
I'm confused.
We have the cube root.
Yes.
Yes?
3.
What is that in exponential form? 16x to the fifth
1/3.
to the 1/3.
Oh, that's
Thank
what you're
you.
asking?
Yes,
Oh.
what is the exponent for the cube root?
My bad.
Is 1/3. So now I gotta simplify. It says reduce, right? So 16 can be broken down to what?
4 squared.
Keep going.
2 to the 3rd. Or not to the 3rd, to the 4th.
So I have 2 to the 4th, x to the 5th, to the 1/3. So that gives me 2 to the what?
To the 1. Well,
What's 4 times a third?
Oh.
What?
4 over 3.
4 over 3. Because we have to distribute this in, don't we?
yes.
X to the
5/3.
5/3. All you're doing is manipulating these, because if you can take them out, can you put them back in?
Yeah.
That's all you're doing, okay?
Can we try this?
You're just trying to change them. This is exactly this. There's no difference. We just wrote it differently. Because I can do a ton of math with this. I can't do very much with this.
Can we
Yes.
try the bottom one before the next one?
You want to do the bottom one first?
Yeah.
Okay. So what do you want to do first?
Oh wait, there's 3.
Well, 81, we should write it as what?
3 to the 4th. Yeah.
3 to the 4th?
Good job.
So 3 to the 4th, A to the 8th, B to the 5th, all to the what? 1/4. And then I do what?
You distribute.
I distribute. So 3 to the first, because 4 over 4 is 1, right? A to the what?
2.
2. And b to the
5 fourths.
5/4.
Hey, no, don't do that.
Just using our product and our power rule. Okay, so, well, it's just a fraction, right?
Yeah.
So what do you want to do first?
Well, we can simplify 125x. Right, like 5 to the third.
Okay, so 125 can be 5 to the third.
Yeah.
We have x to the first and we have x to the fourth. Can we divide that?
Yeah.
So it'd be x to the third, because 4 minus 1. So I have x to the third, y to the second, over 5 cubed, all to the what?
1/3.
1/3. Anybody not understand what just happened?
Can you say that just a little bit slower, what we just did? Wait. So you took the x on the bottom and then just...
Because there's a 1 here,
combined
yes.
them.
I just reduced them.
Right, reduced them, okay.
And so this became 3.
Okay, that makes sense.
It's going to be x to the first, y to the 3 halves, and then it's going to be over.
2/3. No, you said 3 halves.
Okay. And
Minus
5
5.
to 1.
Okay, how'd you do that?
How did I do that?
Yep.
You just did it.
Because there's people in the room that don't know what you did. I know what you
So
did.
I did 3 over 3, which would be 1. Then you did 2 over 3, which equals 2 threes. And then you did 3 over 3, which equals 1.
Okay. I'm just saying, there's people in the room that didn't know how you did it. So are we doing these problems all at one time?
No.
No. We are stepping through them.
Is this
Is that what we're doing? Is this what we're doing?
Basically, yeah.
This is going to be easy.
If you rush yourself, though, they won't. So, okay. Rewrite the product quotient of a radical. Okay. Just, guys, no matter what the directions say, simplify it. Okay? Just do it. Okay, the 5th root of 16 times the 5th root of 8. So, the other ones had to have the same bases, yes? Well, now do we have the same radical? Do we have the same exponent now?
Yes.
Yes. So as long as I have the same bases or the same exponent, I can mix and match, right? So the 5th root of 16 times the 5th root of 8. What would you like to do first?
Well, we can simplify 16 and 8.
Say that again.
We can simplify 16 and 8.
Okay, so 16 is what?
2 to the 4th.
2 to the 4th.
And then 8 is 2 to the 3rd.
So do you want 2 to the 4th to the 1/5? Is that what you want?
Yeah.
Okay. Times 2 to the 3rd to the 1/5. Okay. So now what I would suggest, whether you write it out or not, this is how you need to think about it. If I can distribute in, I can factor out, correct?
Yeah.
So think about it as 2 to the 4th times 2 to the 3rd to the 1/5.
We can write it like that?
Yep. Because if I can distribute it in, Olive, I can factor it out.
Oh, okay.
Because if I wrote it like this, I would distribute it in, wouldn't I?
Yeah.
Okay. So now I have 2 to the what?
2, 4 over 5, and then you have...
No. 2 to the 4th times 2 to the 3 is 2 to the
So the 4.
7th. 2 to the
4 and 3. You add
2 to the 4 times 2 to the 3rd is 2 to the 7th. We're not doing them individually. We're going to combine them first.
And then so 2
Then
to
what
the 7th
happened
to
to
the
the other
1/5.
2?
What other two?
They just,
There's 2 of them.
they went
Okay,
they
they're
have the same
right there and right there.
Yeah.
They have the same base. So
Okay, they have the same base, so you can add the exponents, correct?
Yeah.
Okay, so I now have 2 to the 7th to the 1/5, so I have 2 to the
7/5.
7/5. Does everyone see how that happened?
Yep.
We kind of worked backwards a little bit, didn't we? Okay, so now what do you want to do with this one? How about you try this one now? Because I think it might be the last one. I could be wrong. Was there a whole lot of simplifying on this one? No.
Nice.
Actually, there was none, right?
That one was nice.
But did you get that?
Yes.
No.
Okay, what happened, Cooper?
No idea.
Well, what'd you do?
I don't get the bottom part.
Okay,
Oh, the 2 to the 4.
the 2 to the 4th part?
Mm-hmm.
Okay, so 16 is 4 times 4, which is 2 times 2 times 2 times 2.
Yeah, well, why couldn't you just do 4 to the 2?
Because you need to have it all the way down. You need to have it down as small as you can go.
Alright.
Is that the only part that bothered you? Okay. So this one, we did all that work, and did it really get us anywhere, though? No. But can we do it? Yes. Now, if I were to go backwards, what if I started with this? Do you see all the 1/5 there? So then I would pull it out, and it would look like this, wouldn't it? And then I would do 2 to the 4th and bring that, and it would look like this. So we need to be able to go top to bottom or bottom to top. Oh, I got more. Let me see how much more I got. Oh, I got lots. Fun, fun. Okay. These are just like we just did. You want to do them real quick?
No.
No? You don't want them? Anybody want them?
The second one, yeah.
This one, second one?
Yeah, that one looks strange.
Okay. So what are we going to do first?
Simplify the 27.
Simplify the 27. So the 27 is 3 times 9, which would be 3 times 3 times 3. So it'd be 3 to the 3rd, x to the 2nd, all to the 1/4, yes.
What do you do with the...
And then we would have 3x to the, no, 1/2. Okay. So now we got to do, distribute that, don't I? So that gives me 3 to the 3/4, x to the 1/2, times 3 to the, and x to the, and now I combine like terms, like I put those together.
How does that 3 become a 3/4 at the beginning? 3 to the 3/4.
Because you have a 3 and you have a 1/4.
Oh, never mind. I did it wrong.
Okay, so I have 3 to the 3/4 times 3 to the 1/2. Well, I'm supposed to add those fractions, those exponents, yes?
So
But
3
it-
to the 5/4.
So the half, what Olive is saying is going to become 2/4. So 2 plus 3 is 5.
Sorry.
And then x to the what?
Just X.
X, just x. Because x to the half plus x to the half, or x to the half times x to the half is. So again, it looked, but we just kept using those rules, didn't we? We just kept using them. Do you want to do this other one really quick? This other one's not going to have much happen to it, is it?
No.
It's always just going to be everything to the 1/3.
Okay.
Okay, so remember when we add and subtract radicals, they have to be the same radicand, the same stuff underneath of it, right? So we have to simplify it first. So I have square root of 20 minus the cube root of 16 plus the cube root of 250 minus the square root of 5. So if I'm looking at these two and these two are about the only two I can combine, yes? Because I have the cube root and the square root. Okay. So 20 square root, we're looking for sets of 2. How does that break down? 20 is what times what?
5 times 4.
5 times 4. What's the square root of 4?
2.
2. So I have 2 square root of 5. And
Wait,
then
what?
right here,
Yeah, how did you get 2 square root of 5?
you have the square root of 4 times the square root of 5. What's the square root of 4?
Oh.
2. Back to geometry.
Yeah.
Okay.
2 to the 4th.
Say that again.
2 to the 4th.
2 to the 4th. So I minus the cube root of 2 to the 4th, So that would be, I could bring out one set of 2s, yeah? Like if there's 4, and I'm looking for sets of what? 3, I can bring out 1 and have 1 left over. Okay, 250. Well, that's 25 times 10, right? And 25 and 10. So that's 5 cubed times 2. Because 25 has 2 5s, yes? And 10 has 1 5. And then there's a 2. So what can I bring out of that?
The 2.
No,
5.
I can bring out a 5. The 2's to the first, so I can't bring it out. I need how many? 3. So I can bring out a 5, and I'm left with the square root, not the square root of 2, the cube root of 2. And then minus the square root of 5. So my square roots, do they have the same radican now? It's the number under the square root. Do they have the same?
Yep.
Yes. So I have 2 minus 1 is what? 1. So I have square root of 5. Now the cube roots, do they have the same radican now? Yes. So I have negative 2 plus 5 is what?
3.
So plus 3 cube roots of 2.
Is that it?
That's it.
Okay.
So you got to simplify them first, right? Okay, so 20, square root of 20 minus the square root of 600 minus the square root of 125. So we're all square roots. So as long as we get the same radicans, we can combine them. If not, we can't. So 20, what's the perfect square in 20? 4. So you have 4 times 5, and the square root of 4 is?
2.
So 2 square root of 5. Minus, okay, so 600, how do you want to think? I want to think of that, 100 times 6, yes? Why did I pick 100?
Because it's a perfect square.
It's a perfect square. So the square root of 100 is? 10. And 6 doesn't have anything perfect in it, does it? Okay, so 125.
5. 5's in it. 5 cubed.
Well, it is 5 cubed, but it's like 25 times 5, right? Or 5 cubed. So the square root of 25 is
5.
3 square root of 5. No, it is 5. It is 5.
It's like, how'd you get 3?
Because my brain went 3. Okay, so can I combine all these?
2 of them.
I can combine 2 of them. So I have 2 square root of 5 minus 5 square root of 5 gives me,
Negative 3 square root of 5.
and then just bring down what?
The 10 and 6.
So they have to have the same root and the same radican, and then I can combine them, right? Okay, so the cube root of 2,000 plus 2 square root of 2 minus the cube root. So is square root of 2 going to change? Nope. I got half of the problem right. Yay, yay. Okay. How do you want to do 2,000? We're looking for sets of what here?
3.
3.
Well,
What?
2 times, it's 2 times 1,000, which is 10 cubed.
Okay. So it's 2 times 1,000, which is 10 cubed. Okay. And then I'm going to write it a little differently this time, guys. Okay.
I was wondering why you didn't do that in the first place.
Well, I wanted to ease you in there. Okay. Then 128.
I'm feeling 6, but I don't.
You're still 6.
6 or 9.
6 would not work.
With 9?
No. Okay.
Nope.
This is why. Because 3 doesn't.
Right.
Like, because you get 11.
4.
4. You got 28, so 4, yes?
Yeah.
Okay, so 4 times 32.
4 is a perfect square.
Which is, but we're not looking for squares. We're looking for cubes. And 32 is 4 times 8. which is 4 times
Two.
2. So do I have a cube? Okay, so I'm going to write it 4 cubed.
Dude, you made a snail.
Okay. Okay, so the reason why I did this is I'm going to start using what we've been doing, right?
Yes.
So I'm going to first do the 10 cubed. Why?
Because it cancels each other.
It reduces out to 1, right?
Mm-hmm.
So I'm going to have 10, and then I'm going to have the cube root of 2 plus the square root of 2 minus, what's the next one going to go to? 4, and the cube root of 2. Because if they don't reduce, it's still in the cube root, right?
Yeah.
So
You can add those.
I can add them because I have the same root and the same radicand, yes?
Yeah,
So 10 minus 4 is
6, 3,
6 cube root
cube root 2.
of 2
Yeah,
plus the square root
of 2.
of 2. So we did all these with numbers. Guess what the next slide is?
Ew.
Variables. Actually, variables are easier because then you don't have to break them down. They're already, you know what I mean? You don't have to. Oh, but these aren't variables yet.
Just go to the variable.
Oh, just go on. Okay. So what do you think we do here?
Same thing.
What are we doing? Like, what math does it tell you to do? Multiply. So guess what we're going to do?
No.
Multiply.
It's not right.
So we're going to go multiply, and you're going to multiply. Well, what's in front of this cube root? There's a what? 1. So whole numbers multiply whole numbers. Radicals multiply radicals. Got it?
Yep.
Okay. So that would be 1, that'd be 2, the cube root of 7, wouldn't it?
Yes.
Minus
2 the cube root
not 2.
minus.
There's a 1. So it's the cube root of, now
Oh.
that's going to be the cube root of, I don't want the big number. I've got 7 and I've got 49. So I've got what?
7 the cube.
7 cubed. By doing that, what is the cube root of 7 cubed?
7.
7. So I have 2, the cube root of 7, minus
Minus 7.
7.
Oh, yeah. Not too bad.
No, you're just doing the math, right?
Yep.
So 2x minus the square root of 3 times 2x minus the square root of 3. What do I do? I distribute.
Dude, they're the same thing.
Basically,
Can't we just do 2x?
no, no.
Y? You know what I was gonna
Do the
say.
math, yes. I know exactly what you're going to do. No, you cannot do that. Do the math.
You should be able to.
No.
Wait. How do we multiply the 2x to the negative, or to the...
Same thing as we did over here. Same exact way.
Okay, I didn't know what we did with the x. I did that one up.
You treat it exactly like the 2.
Did we do that squared? Oh, wait. Oh. Oh. That makes sense.
Not pretty, is it? No. But was it hard? No. Remember when you take a square root times a square root, you get what's inside, right? The other way to think of it is it was 3 squared to the 1/2, yes? Yeah?
Yeah. What's it do?
Okay. Am I good?
Yeah.
Those are the same.
Yeah.
Ooh, I want to do this one. Do this one right here.
Oh, which one?
The second one.
I was like, which one's this one?
I know, I'm pointing at it. Can't you see me?
No.
Yes.
No.
Do the second one.
It's just like the last one.
No, it isn't.
No, it's not, because it's got a
What's the difference?
It has one
positive and a negative.
They're the conjugates, right? So when it's a conjugate, are you going to have a middle term ever?
No.
Nope. So it's the first one squared minus the second one squared. Booyah.
That's it.
Do the math and see.
Is that your phone?
No, it's somewhere over there. It's been
That
buzzing since
charging.
the beginning of the period, driving me nuts.
I just heard it.
What is it?
Somebody's phone's ringing. In the basket.
It's mine.
Your phone's not even in the back yet.
I guess. I mean,
Okay, anyway, just do the problem.
Who's calling you this hour?
I don't know.
Is that really what the answer is?
Do it. Prove me wrong.
That's what I got.
That's what I got.
Holy dang.
Okay, so what have we learned about conjugate pairs? What happens to the middle term? It zeroes out, right?
Bye-bye.
So does it make a difference that I gave you a square root?
Yep. Or no?
No. Makes no difference. So if you forget, can you FOIL it out and it will come? Yeah?
I was wondering why we had a middle term on the last one.
Yep. We had a middle term on the last one because why?
They were the same.
They were both negative, right? Okay, so. Okay. So how much time do we got?
2 minutes. 2 minutes.
Okay, we're good for today then.